Hey, welcome everybody. Starting chapter 8. So hopefully everything with your test on 7.3 and 7.4 went well. Um, and we're going to start chapter 8. We are only going to do the first two sections of chapter 8, 8.1 and 8.2. 8.1 has to deal with balancing chemical equations and a little bit about chemical equations and chemical reactions. And then 8.2 is all about um, types of chemical reactions. So you have to do some classifying. There's a third section in chapter 8 on predicting products of chemical reactions. We are going to leave that one out. Okay, so we're going to do 8.1 and 8.2. We'll have an exam on those two sections. Then we'll move on to our final chapter of the year, which is chapter 9. Okay, so as you can see, chemical equations and reactions is chapter 8. And I'm just going to go through some of these slides and then we'll get into balancing reactions. The guided notes are for you in the folder for today, and they're under the chapter 8 folder on your Schoology page as well. So if you want to follow through with your guided notes, that's up to you. Or you can just follow along with this presentation. So a chemical reaction, we talked about this a little bit in chapter 1. Remember, there were two types of changes, physical changes and chemical changes, and another name for a chemical change is a chemical reaction. So that's a process by which one or more substances are changed into one or more different substances. So we actually have a reaction that takes place. What you see on your screen right now, this is two hydrogen molecules, H2 and H2, combining with O2 to form water. Two water molecules, actually. Okay. Little more terminology. We had this in chapter 1 as well. The starting substances are the reactants, and the resulting substances are the products. When you look at a balanced chemical equation, the reactants are always on the left, and the products are always on the right. Okay. And then what we're going to be doing this chapter is writing a chemical equation, and that represents with symbols and with formulas the identities and relative amounts of the reactants and products. So here we have O2 surrounding this balloon filled with H2. When it's ignited, it's very exothermic and it turns into water molecules. So here's the overall reaction that's taking place there. We're going to talk about some of these symbols. We have two hydrogen molecules for every one oxygen molecule, forming two water molecules. Okay, a couple other things in here. These little G's represent gases. So it's just showing you the states of matter. These out here are called coefficients, these numbers out front, okay, and that gives you the relative amounts. So for every two of these, you need one of these, which forms two of those. And we're going to equate those to moles. Those are actually going to be mole amounts of each of the substances, okay? Again, going back to what we learned in chapter 1, what are some indications of chemical reactions? Well, we produce heat and light, we bubble, we produce a gas, we form a precipitate. That's that solid that forms from two liquids. And then you can also have a color change. So, especially when you get a variety of these taking place, it's probably a good indication that a chemical reaction is taking place. So, I have a couple just photos of that. You know, here's a glow stick. That's a chemical reaction. It's producing light. Here's magnesium reacting with hydrochloric acid. That's a bubbling, that's a fizzing, that's production of a gas. Here's a precipitate. This is forming some lead iodide, okay, lead 2 iodide, which is a yellow solid that forms from two liquids. And then here is your color change, okay. Be a little bit careful with color change. Sometimes that only indicates a physical change, but when combined with some of these other things, it's probably going to be chemical, okay. So what do chemical equations have? Well, here are some of the characteristics. They have to represent the known facts. They have to contain the correct formulas of the reactants and products. So that's really what we did in the first section of chapter 7. We learned how to write those formulas. And you must satisfy the law of conservation of mass. So that's where these coefficients are going to come into play. These small whole numbers that you're going to place in front of a chemical equation or in front of a formula in a chemical equation. So it has to be balanced. You have to have the same number of atoms on one side as you do on the other. Remember the law of conservation of mass, Antoine Lavoisier. Matter is neither created nor destroyed in an ordinary chemical or physical change. So that's what we're looking at there. Okay. And here's kind of what we're going to try to do. We're going to take a statement like this eventually and write it into this balanced equation. So this was a reaction of magnesium with oxygen. You did this in your physical and chemical change lab. You actually lit a piece of magnesium on fire. It formed with oxygen and formed magnesium oxide, which was kind of that white little ash that came off of there in this white smoke. Okay, so this statement says when solid magnesium burns in air, so we have solid, that's this S right here, and we're going to get to the symbols here in a minute. Oxygen is combining in the air. That's the part of air that combines with the magnesium. It is a gas, and it forms solid magnesium oxide. Now, these twos, what they represent is just the ratio with which all these react. For every 2 mg's, reacts with 1O2 to form 2 MgO. Okay. Here are some of our symbols that we use in chemical reactions. Some you'll use a lot, some you won't use much at all. The first one, the arrow, that's the yield sign. That splits up the reactants from the products. You'll be using that a lot. This shows a reversible reaction or equilibrium. You won't see that as much in Chem 1. You see that a little bit more in AP chemistry. S represents a solid or precipitate forms. This is alternative to that, especially when it's a precipitate, a down arrow, but we won't use much of that. L means it's a liquid. AQ, aqueous, dissolved in water. So that's different from a liquid, okay? But that's when it's dissolved in water, and a G is a gas. This is alternative to a gas producing, putting an up arrow. We won't use that too often. This is one thing we will use when a reactant is heated. Okay, we put a little triangle over the yield sign, or we just write the word heat. Sometimes you even see the temperature written above there. And this is if you cool it down, but also if you heat it up, you can write the temperature there as well. These two show pressures. Just writing that's not at normal atmospheric pressure, you can just write the term pressure. Here you're writing the actual pressure of 2 atmospheres, and this is if you had a catalyst. Okay, in that case, MnO2. Okay, so balancing chemical equations. Now, these word equations, we are going to do that tomorrow. Okay, we're going to wait and do the word equations tomorrow. So we're just going to do symbol equations, excuse me, today. But that's the one thing you have to do. If words are given, you have to write it correctly. And that's kind of going back to what we did in 7.1. Okay, so balance the formula equation according to the law of conservation of mass. Balance the different types of atoms one at a time. Balance the atoms of elements that are only purely once on each side. Sometimes you can take polyatomic ions and keep them together. And then finally, and you don't always have to do this, these are kind of just guidelines, but I usually save hydrogen and oxygen till last. Okay. And then make sure at the end that you count the atoms to be sure the equation is balanced. The yield sign or the arrow is what breaks it up. So what you have before that has to be the same number of atoms as what you have after it. Okay, so here are some examples. Okay, we're going to do these first 3, and then tomorrow we're going to come back and do these other 2. Okay, so to start out, what I have here for you is just I have little blanks written in here. Normally you won't see those in reactions. The numbers just filled in, but for practicing balancing, we're going to use that first. Okay, you're also going to do an activity today, a PhET simulation on balancing, that'll help you out as well. Okay, so let me get my pen down here, and I don't have to write much, just numbers, which is good until tomorrow when I have to write those formulas out. So let's get our pen going here. So we have N2 here. This 2 represents that there's 2 N's. Now over here, there's 1 N. Okay, so as written, we're starting with 2 and ending with 1, and we can't do that. If you start with 2, you have to end with 2. Now, you can't change the formula. I couldn't write a subscript of 2 here. I can only use coefficients, okay, going in these blanks. So I'm going to put a 2 out front to show now that I have 2 N's and 2 N's here. This 2 represents this whole molecule, NH3. So not only now do I have 2 N's, but I have two H3s. So H3, H3, so 6 H's. So I have 6 H's over here, and I only have 2 over here. So I need 3 over here on this side to make 6 total. So if I put a 3 right in there, now I have 3 H2s. So H2, H2, H2. So instead of writing that all out as 3 H2s, you can just write the number, 3 H2s. Okay, so now check to see. Here's our, you don't have to draw this line, but that's where we separate. The same number here as we do here. So N2, 2 N's, 2 N's. 3 H2s, 6 H's. 2 H3s, 6 H's. So that is balanced. Okay, you don't necessarily have to, I'll erase this line right there. There we go. You don't have to write a 1. You're really not supposed to write a 1 here. Just writing N2 shows that there is 1. You really don't need to write a 1 there. Okay, so let's try this next one. KClO3 yielding KCl plus O2. So let's start with the K first. There's 1 there. There's 1 there. That's good. K is balanced. Cl, 1 there, 1 there. That one's balanced. Now O, 3 here, 2 here. Now that's a problem because we have 3, we end with 2. So we have to end with 3, or we have to end with the same amount. So there's, you could put 1.5 in front of here. And 1.5 times 2 would be 3. But these have to be whole numbers, these coefficients. So we're going to have to change 2 things here. We're going to have to make a common amount of oxygen on each side. That common amount is going to be 6. So if I put a 3 out front of here, that's going to give me 6 O's on this side. Now, the only place I can get to make 6 here, I can't change this to a 6. I can't put a 2 in the middle of the formula. I have to put it out front. Okay, now that's going to change my balancing for the K and the Cl, but that's fine. I can still balance that. Okay, so now I have 2 O3s and 3 O2s. That's 6 and 6. But now I have 2 Ks, and I need 2 Ks here. But with putting that 2 out front here, I have 2 Cls and 2 Cls. Okay, so we're good there. Okay, so let's just check it. Here's a yield sign. 2K, 2K, 2Cl, 2Cl, 2 O3, 6 Os, 3 O2s, 6 Os. So that one's good. Okay, that one's balanced. It's balanced 2. And you just say the number. 2KClO3 yields 2KCl plus 3O2. Now this last one. Okay, well, let's just start to count some things. I know there's a lot to it and there's a lot of blanks, but let's just take a look. Na, 1 there, 1 there. That's good. N, 1 there, 1 there. That's good. C, 1 there, 1 there. Notice I'm keeping my H's and O's till the end. Okay, that usually helps out. Now I'll do my hydrogens. 1, 2 total. Okay, H2, 2 total. And then finally, O3, O3, there's 6 O's, 3, 4, 5, 6. So this one is already balanced. You didn't need to put any coefficients. Sometimes that does happen, but you still have to check it, okay? Even though you don't need any coefficients in front of there, okay? So 2 things you have to do for tomorrow. Make sure you go through and do the balancing equations homework, okay? You just have to do these symbol equations, fill in the blanks, and then check your work and make sure you fill out the assessment. And then there's an assignment that you have to do where you have to log onto your PhET and do balancing chemical equations. There's a worksheet that you have to upload with that. So make sure you do that as well. If you have any questions, please let me know.